Today, we are going to start the next question from the exercise 2.5. Question number 4, we are going to start. Actually, we have considered up to question number 3 from the same exercise 2.5. And in that exercise, we are considering about the fractions and decimals. So already we have considered the fraction part, total part we have covered, and now we are considering the decimals. We are dealing with the decimal numbers, different kinds of decimal numbers, and regarding those concepts, what are the concepts which are related to the fractional numbers that we are studying in this exercise. So here from exercise 2.5 already up to question number 3 we have covered. Now we are going to consider the question number 4, express in kilogram. Now actually we have solved such a type of example in previous lecture, which is actually express in kilometer. So in similar way, here we are going to consider express in kilogram. Express in kilogram. Now, as we have to express these quantities or these numbers in kilogram, then obviously we should know the conversion of kilogram and gram. That means we should know the relation between kilogram and gram. Without that relation, we are not able to convert them from gram to kilogram, like we have converted from centimeter to meter or meter to kilometer. In the same way, we are going to convert it from gram to kilogram, but for that purpose we should know the values for 1 gram how much kilogram is there, or for 1 kilogram how much gram is there. So such a value should be known, then only we are able to solve such a type of example. So here, as we know that, or we are seeing in the stores, you are seeing the weight, so weight machine. On that weight machine you can easily see that for 1000 gram 1 kilogram is there. You know that, you are seeing that electronic weight machine. So on that you can see these numbers. So if that number is 1000 gram, then it is indicating 1 kilogram. So here the value of 1000 gram is going to be 1 kilogram. So that is the relation between gram and kilogram, which we are going to use in this example. Now, from this relation, we are going to calculate the value of gram, the value of 1 gram. We are going to calculate the value of 1 gram. So for that purpose, there is nothing to do. We have to just shift this 1000 from left hand side to the right hand side. We are going to send this 1000, that means we are going to transpose that 1000 from left hand side to the right hand side. And we know that while shifting or while transposing the number from one side to another side, its operation is reversing. So here we are going to shift this 1000 from LHS to RHS, and on the LHS it is at numerator, that means it is at multiplication. So reverse of multiplication is going to be division. So therefore on other side it is going to on denominator. So therefore we obtain it like this: 1 gram is equals to 1 gram is equals to 1, that will be as it is, and divided by 1000, which we have taken from the left hand side, which goes to denominator, and that kilogram is going to be as it is. So here value of 1 gram is going to be 1 upon 1000 kilogram, or by dividing that we can get the answer 0.001 kilogram. So while dividing with the help of 10, 100, 1000, we have to just shift the decimal point to the left side by number of zeros. So here in 1000, 3 zeros are there. So we have shifted the decimal point 3 digit to the left side. You can see here, this is the first digit, this is second, and this is third digit. So total 3 digits we have shifted the decimal point to the left side if we are dividing by the 10, 100 or 1000. So you have to just see how much zeros are there and you have to shift those number of digits to the left side. So here 3 zeros are there, so that's why we have shifted it 3 digits to the left side. Now by using this relation, we are going to solve the first example, which is conversion. That means we have to convert this 200 gram into kilogram. Now obviously it is in gram and we have to convert it into kilogram. So instead of gram, we have to replace it by kilogram. And for that purpose, we are going to use this relation. 1 gram is equals to 1 upon 1000 kilogram, or we can also put the value 0.001 kilogram. That value also acceptable, no problem. That value also we can use. So any relation we can use, either 1 upon 1000 kilogram or 0.001 kilogram. Now, in order to convert this 200 gram, we are going to keep that 200 as it is. So this 200 is going to remain as it is, and we are going to multiply it with the value of 1 gram. We are going to split that 200 and 1 gram. So 200 into 1, 200 gram, that is going to remain as it is. So therefore, the conversion is like this: 200 into, so this 200 is remained as it is, into, we had used the conversion. So here value of 1 gram just we have kept in multiplication place. So therefore 1 upon 1000. Now we know that if we are dividing by 1000, then in 1000 3 zeros are there. So we have to shift the decimal point to the left hand side by 3 digits. So here in 200, we are going to shift that decimal digit to the left side by 3 digits. So if we count the number of digits, 1, 2 and 3. So before 2, that decimal point is going to come. Or you can also use the second method. That means you can also multiply by 0.001. No problem. Any method you are going to obtain. And by again multiplying or shifting the decimal point. So final answer is going to be 0.200 kilogram. This is the final answer. You can see that I had shifted the 3 decimal digits, 002. So that means decimal point is shifted by 3 digits, because in 1000 3 digits, 3 zeros are there. So we have to shift that decimal point by 3 digits. So in this way we can obtain the value of 200 gram in terms of kilogram, and for that purpose we have used the relation 1 gram is equals to 1 upon 1000 kilogram or 0.01 kilogram. Any relation you can use. Now we are going to move to the next example, second example actually, again, which is going to be similar to first example. That means again we have to convert from gram to the kilogram. Now here little bit higher number is given. That means 3470 gram, that should be converted into kilogram. So here we are going to convert 3470 gram into kilogram. Now again same methods we are going to follow. Whatever be the methods we have followed in the first example, that only method we are going to follow in the second example also. That means all the steps are going to remain same. That means the steps are not going to change. So these steps are going to remain as it is. So in the first example, we had multiplied that 200 gram with the help of 1 upon 1000 or 0.01. So in the same way here, for 3470 gram, we are going to multiply it by 1 upon 1000 or 0.001. So any method you can use. Here I am indicating both the methods. You can use any one method. That means if you want to take only this first method, then it is okay. If you want to take this second method only, that also you can take. So that means it is up to you which method is suitable for you. That method you can use. Either you can divide it by 1000 or you can multiply it by 0.001. Both methods are acceptable and both are actually easy. So any method you can use. So here if we divide this 3470 with the help of 1000, now again you have to count how many zeros are present in 1000. So if we count those number of zeros, it is clear that there are 3 zeros, 1, 2, 3 zeros are there. So while dividing with the help of 1000, for whole number, we are going to shift that decimal point to the left side by 3 digits because 3 zeros are there. So here we are going to shift the decimal point to the left side by 3 digits. So you have to count the 3 digits in the number 3470. So 0 is the first digit, 7 is the second digit, and 4 is the third digit. So that decimal point is going to be between 3 and 4. That means you have to place that decimal digit between decimal point between 3 and 4, and by keeping or by putting that decimal point, we are going to get the answer like this: 3.470 kilogram. 3.470 kilogram. And if you take the multiplication of 3470 and 0.001, then it is also going to be same 3.470, which is the final answer, or we can say that final conversion of gram into kilogram. So you can say that 3470 gram is considered as 3.470 kilogram. Now we are going to move to the third example, the last example from question number 4. Again, we have to express in kilogram, and this number is little bit different. Now, actually two numbers are given. One is already in kilogram. You can see it clearly, 4 kilogram. So it is already in kilogram. It is already in kilogram. And the second number is 8 gram. 8 gram. So it is in gram. So here we have to convert only the second digit or second number. That means 8 gram should be converted into kilogram, and then we have to add whatever be the answer is coming for that 8 gram. We have to just add that value into 4 kilogram. So here 4 kilogram is going to remain as it is. 4 kilogram is going to remain as it is. So do not change that 4 kilogram. Only we have to convert this 8 gram. What we have to convert? We have to convert only 8 gram. So therefore, in first step, 4 kilogram is going to remain unchanged. So here we have kept that 4 kilogram unchanged. That is not going to remain. That is not going to change. So it is going to same 4 kilogram plus, because we have to add the remaining value, 8 gram value we have to add in that 4 kilogram. So therefore we have used the plus sign. Then before adding that 8 gram, we have to convert it into kilogram. We have to convert it into kilogram. So therefore 8 into 1 upon 1000, or again the second method you can use. Instead of 1 upon 1000, you can also use 0.001. So now here this second method is easier because whole number is only single digit. So you know that 8 into 1, 8. So you are going to get the answer like this: 0.008 kilogram. So sometimes first method is easy, sometimes second method is easy. That means here only a single digit is there. So in that case, multiplication is going to be simpler because 8 ones are 8 and remaining zeros and decimal point are remain as it is. So 0.008 kilogram is the conversion of 8 gram into kilogram. Now we have to just add these two values, 4 kilogram and 0.008 kilogram, and by adding those two values we are getting 4.008 kilogram is the final conversion of 4 kilogram and 8 gram, that is converted into kilogram like this, 4.008 kilogram. So in this way we can convert the gram value into kilogram value with the help of relation 1 gram, which is equals to 1 upon 1000 kilogram, or 0.001 kilogram. It depends on condition, or it depends on you which step you are going to use. If you multiply by 1 upon 1000, no problem, or if you multiply by 0.001, then also no problem. So this is the question number 4 from the exercise 2.5. Now we are going to start the next question, question number 5 from the same exercise 2.5, which we are studying. In question number 4, we have converted gram into kilogram. Now here, the next type of question we are going to consider, and here we are going to consider the expanded form. Now, which is the next concept, or we can say the further steps in order to explain or in order to denote the decimal numbers. Now we are dealing with the decimal numbers. Actually we are studying about the decimal numbers, and in that decimal numbers we have seen the conversion, that means the whole number is converted into decimal point by converting one unit into another unit, like we have converted millimeter into centimeter, or centimeter into meter, or meter into kilometer, gram into kilogram, like this we have converted, or rupees into paise, or paise into rupees, like this we have converted the all the questions we have considered in the previous questions. Now here we are going to consider the expanded form for the given decimal numbers. Now actually if we consider the positions of the numbers, that means we are expressing the positions of decimal digits. Suppose if you consider the first example, suppose here the first example is 20.03. This is the first example. Now here if we consider this 20.03, which is actually the decimal number, that means if we are going to consider the nature of that number, it is going to be decimal number, not, it is not a fraction or it is not a whole number. So we can easily spot the difference between whole number, fractional number, then the decimal digits, like this. So here this is the decimal number. So if we consider 20.03, which is a decimal number, actually it is a decimal number. Now if we consider the position of any digit, then in the first lecture we have discussed that the position of the numbers which are present on the left hand side of the decimal point, that is referred as the integral part, and the numbers which are present on the right hand side of the decimal point, they are referred as a decimal part, that is referred as a decimal part. So here if we consider this particular number 20.03, in this 20.03 the number 20 is referred as an integral part, because it is present on left hand side of the decimal digit, and the 03, it is referred as a decimal part because it is present on the right hand side of the decimal point. So therefore it is referred as a decimal part. Now if we indicate the position of numbers which are present on the left hand side, that means if we are going to present the position of integral part, then we are expressing it like this. it is present at tens place, or it is present at units place, or it is present at hundreds place, like this. And if we consider the position of decimal part, then we are referring it like 10th place or 100th place. That means we are using the th word, the position, and after that position we are adding the th word. And if in case of integral part we are adding s only. Suppose 10, we are using tens in case of integral part. Then in case of decimal part we are using th, that means 10 is referred as a 10th position, like this. So here if we compare the positions, if we compare the positions, then here suppose for this number 20.03, if you are going to consider the position of 0, this 0 which is in the integral part, then we know that it is present at units place. The first digit is always units place, like 1 2 3 4 5, they are the units place. So here the first digit of 20, which is 0, which is referred as a units place. And if we move to the left hand side, then next digit is 2, next digit is going to be 2. So this 2 is tens place. If we move further, then we are getting hundreds place, like this. But here only units place and tens place are present. So therefore these two digits are having the position units and tens position. Then if we move to the decimal part, which is 03, and if we consider this first 0, then that 0 is present at 10th place. It is present at 10th place. So therefore we are going to refer it as a tens place. So therefore it is our tens place. Then after 10th place we are moving further, then it is going to be 100th place. So this 3 is going to be referred as a 100th place. Then if you take another number, then it is 1000th place, like this. So here whatever be the position of that number is, it is very important, and by using these positions we are going to expand the given decimal number. Now we are going to consider the first digit, which is 2. First digit of 20.03 is 2, and if we compare the position of that number, then it is obviously present at tens place. So 2 is present at tens place. So therefore here while expanding we are going to multiply that 2 or that digit with the help of place of that digit. So here 2 is present at tens place. So therefore we are going to multiply it by using 10. So 2 into 10 we are going to consider. Then next number is added. Next number is added. So next number is 0 plus 0 into, now position of 0 is units place. So units place is considered as 1. So therefore we are going to multiply that 0 with 1. We are multiplying that 0 with 1. Then ignore the decimal point. After decimal point, the next number is 0. The next number is 0. Now that 0 is present at 10th place, that means 1/10th place. So therefore that 0 is going to multiply by 1 upon 10. 10th means 1 upon 10. So we have to multiply it with the help of 1 upon 10. Then next number is again added, which is 3. 3 into the position of 3 is 100th place. So 100th means 1 upon 100. So therefore we are going to multiply it by 1 upon 100. So in this way, this is the expanded form of the 20.03. So just remember, while expanding or while writing in expanding form or expanded form, you have to consider position of each digit, and you have to multiply by that position to that digit, and next digit is added to first digit. So in this way we have added 2 into 10. 2 is present at tens place. plus 0 into 1. 0 is present at units place or ones place. Then 0, next 0 is present at 10th place. So we are multiplying it by 1 upon 10. Plus 3 is present at 100th place. So we are multiplying it by 1 upon 100. So in this way, we can convert it into expanded form. Now, in the second example, again, same thing we have to perform. That means same way we are going to perform the particular uh, that operations. Now, the next example is 2.03. The next example is like this, 2.03. Now, again, we have to identify the positions of the numbers which are in the given decimal number. So here now only 3 digits are there, 2.03. So only 3 digits are there, and we are going to consider the position of those digits. So again, just see, 2 is present on the left hand side of the decimal point. So it is referred as an integral part. And 0.3 is present on after the decimal point. That means it is present on the right hand side. So definitely it is going to be the decimal part. Now, if we compare the decimal part of the first example and of the second example, quite similarity is there. That means they are same. So as in the example number 1, we have to perform the same steps for the 0.3. That means the portion which is present after the decimal point. But the integral part is different. In the first example, the integral part is 20. And in the second example, the integral part is 2. Integral part is 2. So therefore, we have to consider this integral part 2. Now, obviously that single digit is there. And we know that if single digit is there, then its position is always units place, or it is referred as a ones place. So therefore, while expanding it, we have to multiply that 2 by 1 because it is present at units place or ones place. So therefore, we are multiplying it by 1. Now we have to add the remaining numbers. Plus 0 into 1 upon 10 because 0 is present at 10th position. 0 is present at 10th position, and plus 3 into 1 upon 100 because 3 is present at 100th position. It is present at 100th position. So in this way, we have expanded the second question, which is regarding the 2.03. So which is the expanded form can be considered as 2 into 1 plus 0 into 1 upon 10 plus 3 into 1 upon 100. So in this way, we have expanded 2.0. Now, in the same way, we have to expand the third sub question, which is 200.03. Now, again, if we compare this 200.03 with the first two examples, and if we consider the similarity, then here there is only one similarity is there. The decimal part is same as that of in the first and second question. So here decimal part is going to remain as it is. But integral part is different. In the first example, 20 is there. In second example, 2 is there. And now in the third example, 200 is there. So therefore, obviously the expanded form of the integral part is going to change. And for that purpose, we have to consider the positions of each and every digit. So we are going to start with 2. So first of all, I am going to consider this 2. So here only 2 we are going to consider. Now, if we consider the position of this 2, if we consider the position of this 2, then its position is like this. We are moving from 0, units place, then tens place, then hundreds place. So here the position of 2 is hundreds place. It is present at hundreds place. So therefore, we are going to multiply that 2 by its position, that means 100, because it is present at hundreds place. It is present at hundreds place, so therefore we are multiplying it by 100. So therefore first multiplication we got like this, 2 into 100, that is the first expansion. Now second expansion we have to perform, plus next digit is 0, next number is 0, and now it is present at tens place. 0 is present at tens place, so therefore we are going to multiply it by 10. So therefore we are getting the second expansion like this, 0 into 10, because 0 is present at tens place. Now next one, again 0 is there. This is the last 0 from integral part. This is the last 0 from integral part, and last 0 means it is obviously present at ones place or units place, so therefore it should be multiplied by 1. So 0 into 1, then plus remaining part is going to remain as it is, as in the first and second example. 0 is present at 10th place, so next 0 is present at 10th place, so therefore we are multiplying it by 1 upon 10. 0 into 1 upon 10, plus last digit is 3, which is present at 100th position, so it is taken as 3 into 1 upon 100. So in this way we can expand the given number or given decimal number, and we can write it in the expanded form as we have considered in question number 1, 2 and 3, which are the sub questions of question number 5 from the exercise 2.5.